Okay, now we're back. What was that? 5 minutes of brain relaxation. Okay, that ax squared, they explain it this way. With a non-zero a, you're going to have a curve either going up or going down. And of course, it depends on whether a is positive or negative. Positive a, curve up, negative curve down. Oh, there's something here. Remember how in the quadratic formula have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Do you see that where it crosses is going to be negative b over 2a plus or minus the square root of b squared minus 4ac over 2a, meaning negative b over 2a, there's the plus side, there's the minus side. It's going to cross exactly two sides of negative b over 2a. So analyzing it closer, we see that this is our line of symmetry, meaning that's going to be the center of my curve. If anyone says, okay, where's your curve going to be the smallest or largest? Well, I know b over 2a is a curve. Negative b over 2a is where it's going to either be the lowest point or the highest point. And that point where it's lowest or highest, if this is actually representing some real problem in the real world, it's either where you're making the most money or you're losing the most money. Where your formula is balanced or your formula will blow, or your experiment will blow up. That's a inflection point of a curve. Not all, of course, depends on what your formula represents. If it represents the temperature of your chemical reaction, that'll be either where it gets the hottest, and I better be ready for it, or where it gets the lowest, and then I'll know I'm in that lowest temperature. If I can attach a formula like a quadratic to some real world experiment, that negative b over 2a will tell me my experiment, there's something important going to happen where at negative b over 2a. The curve is going to be the lowest or the highest. The rocket will get the best thrust when I have that formula negative b over 2a right there, or it's going to be where it doesn't get enough thrust or where I land and I have the lowest altitude. So that's the turning point of my curve. Now, I don't know if it's minimum or maximum, but what's an easy way to tell whether it's a minimum or maximum? Remember, when a is greater than 0, I know my curve is going up. So if I know a is greater than 0, I know b over 2a, negative b over 2a is going to be my minimum. If a is positive, or sorry, if a is negative, I know then negative b over 2a is going to be the maximum of my curve, because I know the curvature all depends on the sign of a. So just like we looked at the discriminant, now looking at b over 2a becomes a useful thing to consider. Even without knowing the exact values and calculating them, I can tell you where my important place in my formula is going to be a curving up or down with the minimum or maximum at that point. And then I just go look at the values of a and negative b over 2a. Okay, so I can answer these questions without solving everything. I would probably solve the quadratic formula first and just have everything, but let's just answer the questions without even having to do any math. Does it open up or down? Down, because yeah, a is negative. So a less than 0, it opens down. It's going to look like that. Does it have a maximum or minimum? Well, duh. If it opens down, that means it has a maximum. When it opens up, it has a minimum. Line of symmetry. Oh, I have to start doing some calculation. Negative b over 2a. Okay. Line of symmetry. Negative b over 2a. Negative b is negative negative 4. So negative negative 4 or 4 all over 2a. 2 times negative 2. Okay. Well, that becomes negative 4. This becomes positive 4. So 4 over negative 4 equals negative 1. So line of symmetry, negative 1. Came out to be a simple answer. The vertex, well, that means I need to know what the value is at that point. So I know the x is negative 1, right? I know b, the line of symmetry at x is equal to negative 1. What do I do to find the vertex? Well, I plug negative 1 into my f of x. To find the vertex, I have to say negative 2 times negative 1 squared minus 4 times a negative 1 plus a 1. And figure out what that is. Negative 2 times 1 squared, or negative 1 squared is 1. So negative 2 minus 4 times negative 1, that becomes a plus 4 plus 1 equals 3. So my vertex is at x equals negative 1, y equal to 3. That's my vertex. So I can start looking on the graph. Negative 1, 3 is like about here. I know it's going to curve down, something like that. Oh, to find the y-intercept, well, that's when x is equal to 0. Oh, look at that. When x equals to 0, I get a 1. So the y-intercept is at 1. So y-intercept is 1. X-intercepts, now I got to use the quadratic formula. It's the easiest way, because x-intercepts means where is f of x equal to 0, or negative 2x squared minus 4x plus 1 equal to 0. Quadratic formula time. Negative b 4 plus or minus the square root of b squared 16 minus 4 times a negative 2 times a 1, or 16 plus 8. All over 2 times negative 2, or negative 4. 16 plus 8 gives me 24. 4 plus or minus, well, let's see, 24 is 4 times 6. And there's no other squareds except a 2 squared in there. So 4 plus or minus 2 square root of 6 all over negative 4. Factor out a 2, 2 plus or minus square root of 6 over negative 2. I can bring the negative 2 up above and say negative 2 plus or minus square root of 6 over 2. The sign can go top or bottom. Those are my x-intercepts. That was the hardest answer. Otherwise, it was not even having to solve the quadratic formula, just pieces of it. See if they got the same answer. Yes, they did. 2 plus or minus square root of 6 over negative 2. So they did all the work for us later on just to check, did we do it right? Yep, opens down. Since it opens down, it has a maximum. X equals negative 1 is the vertex, like just by solving negative b over 2a. And then plugging in negative 1 to find what is f of negative 1 gives me that point for my vertex. And then the very last one, this one was easy. X equals 0 gives me an easy answer. But the hardest one is those x-intercepts. That's where you have to crank it out through the quadratic formula. And graphing it, I would go to GeoGebra and graph it. And you'll get that just to verify, yeah, that makes sense. Now they just talk about this increasing or decreasing on an interval. It's kind of just doing a little more different look at this particular graph. Just to describe a graph, I know that it's increasing starting here. So I can see it's increasing on the open interval. The open interval means it's not increasing right there at, looks like x is negative 1. So I would say not at negative 1, but all the way positive, it is increasing. And of course, you never get to positive infinity, so you never make that a square bracket, because you can't, it's impossible ever to get there. Decreasing, of course, all the way out to negative infinity, not quite to negative 1. Here's the decreasing part, coming down, going up, all around that line of symmetry. Well, I can see from this graph, they made it simple. My line of symmetry is at x equals negative 1. And the minimum value is at negative 4. So it has a minimum of negative 4 at x equals negative 1. All just looking at the graph. I don't have to worry about finding the formula. But have you noticed, I know from this graph that negative b over 2a is going to be equal to negative 1. That is going to have a factor at equals 0 at negative 3 and 1. So solution for f of x equals 0 are at x equals negative 3 and positive 1, then I know that that's going to be x plus 3 times x minus 1 equals 0. If I know of it, that that's where it crosses x, and look at that, if I multiply that out, I know that my function is going to be x squared plus 3x minus x plus 2x minus 3 equals 0. I forgot my x in there. So from factoring it, I can guess what that formula is. Positive, line of symmetry at negative 1. Hey, I think I found what the formula is, just because I could see where it crosses my x-axis. So they go through that, giving you the various values. They never worry about actually finding the formula for the function. All right, last, we'll end the day with a word problem. All we have to do is crank out mathematical formulas that relate to what's being told us. Gardener has 500 feet of fencing to fence in a rectangular garden, okay? Total around is going to equal 500. So I know, let's see, I have a width. No, that's my length. I have a length and a width, and I know that 2 times the length plus 2 times width is going to be equal 500 feet. Are we putting the fence along the river? I believe we are. Oh, no, there's not fencing needed at the river. So it's only length times width. We'll erase that. It's only length plus 2 times width gives me 500. I don't need to put a fence along the river. Well, there's their formula. 2 W's plus 1 L equals 500. But we want to find the dimension of the greatest possible area. Well, area is length times width. Okay, so area is LW. Well, it doesn't get us anywhere. We do want to get a maximum LW. So think of maximum LW. Well, we already have from the first formula, 2W plus L gives us 500. Or L is 500 minus 2W. Well, I can substitute for L up here and do 500 minus 2W times W is my area. And what do I want to do? I want to get a max of that. Well, that means where is the vertex of this curve, 500W minus 2W squared? That's what I want to maximize. And they show you, I can just calculate the line of symmetry and right away know what my W is for the line of symmetry. And I'll just take you there really quick. B over 2A gives me 125 for my W. Therefore, that's the maximum of my area. Don't have to worry about what the curve is. All I have to worry about is what W gives me that maximum. Well, I know that a W of 125, that means my L is 250. So an area of 125 by 250 gives me my maximum area that I could fence with 500 feet of fencing on 3 sides of a pasture. So those animals will be happiest possible animals if I use my math and maximize the area I can give them, fencing them in, keeping the predators out. As long as they don't swim across the river, my little animals are going to, my garden's going to be safe. We can still get predators coming across the river eating up the carrots. But anything that can't swim will be kept out of my maximum size garden. All right, we will stop there. We'll finish up this next time. We'll be about halfway through that. And then give you more practice. Have a great day.